Alright, back at it again. So we got to figure out our bolt depths now. So now that we got our change shoe fixed, not going to fall apart like it was. I got to figure out how much bolts we can put on here and have maximum holding power. So what you do is you take a bolt, you have a lock on it, you have a flat washer on it, like you're going to use it. You can check to see by putting it in and see if it tightens down. The only problem is you don't know what it's getting tight against. So what you do is you take the lock washer out of the picture, run the bolt in the washer only. And then we see if it'll touch against this. If it does, we're golden. If it doesn't, we got a problem. So we can either put this fancy one on top or on the bottom. I think it's better to be closer to this end. More holding power. So let's find out if these bolts bottom out. I'm pretty sure they're going to bottom out, because the holes aren't very deep in this thing. If I knew they were that shallow, I would have tapped them deeper. Okay, well, it went deep enough. The shoe got tight. See, tighten the bolt down here, and shoe got tight. See, loosen up, shoe's loose. Boom, it's getting tight. So that bolt's perfect length. Okay, loosen this one up. Tighten this one up. That one bottoms out. So this one you can't put a real long one on. It's an 1/8 inch too long of a bolt. So we gotta take it out, get a shorter one. I don't want to tap the case deeper because it's already been cleaned. Okay, so now I can go find me a shorter one. This is an 1/8 inch, 1 inch long bolt probably. So we need something like a 7/8. Even that looks like it might not be enough. Yeah, it looks like about this length is what I need, but I don't want a stainless, I want a real bolt. So we're going to find ourselves a real bolt that's made out of real metal and not made out of bubble gum. And preferably something that's not too foreign in nature. Alright, I'll be back. Okay, stainless bolt, good bolt. Grade 2, grade 5. Big difference in quality. Okay, so thin washer, short bolt, upper hole. Shoe got tight now, see? Okay, so we got our combo hardware figured out. So now all we got to do is put our lock washers back under the heads, and we know we're going to get full torque without bottoming out and causing any issues, as long as we don't strip anything. So that's how much thread we're going to have. That's how much we're going to in the case. This one we're going to have less, quite a bit less. I don't like being that less because I can't torque it as much, but oh well, it is what it is. Okay, so what do we got now? We got our clutch fixed. One thing I want to show you on these clutches. I'm tired. Okay, I'll rotate this around for you to see, not me. So, if you can take your clutch and turn the hub like this, if the basket's not wobbling really bad, that's a good sign. See how it wobbles a little bit? You're going to get some of that. Hopefully it's not too awful bad. The other thing is you got to rotate it like that and make sure it's not wobbling just by spinning it. Now, if we're going like that and it's not wobbling, that means the basket's straight. If you're going like this, that means how it's being all assembled. It's kind of, something's out of whack as you're rotating it. So that means probably it's the way the hub is on the splines, the way the the splines are cut through the hub. You know, how all this stuff here is made inside of here makes a difference. This is all your tolerance stack ups when you're doing this crap. So you just got to determine where the problem is at. So I know the basket's straight. When I rotate it, it doesn't wobble. If it was wobbling when I rotate it, it's bent. You can go in there and straighten them a little bit on a press and work on a little bit. They're just kind of a big stamp bill, so you can kind of tweak it and make it stay straight. But when you got a hub that's bent, I can't compensate this to make that straight, because every time I move that, it's in a different spot. So this has to be straight. The hub is what it's going to be. That's however it goes together, that's what you get. The motor sprockets are the same way. As these things rotate, hopefully they're straight. This one I didn't look at yet. It wobbles a little bit. Not super bad, but a little bit. About 30 thou. So as these things move, these move. You got offset changes. All of this stuff is going all over the damn place. That's why your chain, you want to have it relatively close so it has maximum flex without getting any damage. A chain, if you yank on it sideways, it'll snap it. You want to pull straight. If you got any kind of side load on a chain, making like an S-bend or a curve, it won't like it. It will break. Especially on a high RPM surface like this. You got a lot of surface speed going inside your primary. Not like the rear wheel, it's going real slow. This thing's hauling ass. And it will tear chains up. That's what breaks stuff. So all these alignments do matter. Okay. Yeah, that didn't fall off. Oh well. That one did. I like that. At least something worked. Okay, we got to get this out. This takes a couple of bolts in here and a harmonic balance puller to do it. See, 2-jaw puller pulls that out with the bolt heads. You can also go around the outside and pull on that the whole thing. But you got to be careful about breaking teeth off. It's not hard to do. Trust me, I know how to break them just as good as anybody else. So we need a puller and a bolt. So we got this version, we got this version here. Doesn't matter which one you use as long as it works. This one's closer, we're going to use it. So this just goes in these bolts right here like this. You need to go in there about 1 diameter bolt. It's plenty in. And pull it off. Now the tighter the sprocket is, the bigger the bolts need to be, the more thread engagement you need to have, the stronger your piece of crap puller needs to be. All that stuff starts to matter. If it doesn't have much press fit on it, it comes out pretty easy. You want your bolts to be on it evenly. Right now this one's out too far. It doesn't want to go in anymore. So that means I got to unscrew this one a little bit. We don't have much room to work that direction, but you want to get where it's pulling straight. Let me just undo this here. So you can do this stuff with hand tools, you don't have to have power tools. Take that much longer to do it. It's always nice to put your puller back where you started so it's easier to use next time. Alright, that's out. Okay. Alright, what do we have to do next? Okay, we got to figure out what we're going to do about this O-ring on here that didn't fit before. This thing has a very sharp edge on the inside, which is going to tear the piss out of that O-ring. So we need to deburr that edge somehow. I'm sure everybody's got a good idea how to do that, right? So that's number one on the list right now, is deburring the hole. I need to get to the machine shop. We got to find a deburring tool that works. The best one's over here by the lathe. Fancy new one I got here I bought. It's hard to get in dull, but okay. Now these are made to do out the outside like that. To do the inside, you got to hold them at an angle and hope you can bite them. But see, this doesn't have a sharp edge all the way in. It's got a ball on it. It's precluding me from doing it that direction, but we're going to try to do it that way anyway. Looks like I'm just getting hold of it. Helped a little bit. Every little bit helps. Doesn't take much to cut an O-ring off. When the O-ring gets cut, it leaks. Alright. Now we got to see if this even going over an O-ring. Okay, where's that O-ring that was over here? Okay, that's the one we pulled off. I don't think that's the right O-ring. So let's find out. So you put the O-ring across the surface and you see how much is sticking above the top of the surface that you got it on. And that tells you how much you got to work with. In this case, it sticks up pretty damn high. Another way to figure it out is you measure with a caliper. See how deep it is. Looks like around 52 deep. And you measure your O-ring. 88. 52 from 80 is 25 thousandths. So this thing is sticking up 25 thousandths in the air. You're going to have to compress it down 25 thou to get this to go through, minus whatever clearance we have here. We probably got about 10 thou at least. So that one is what? 92.3. Let's see, 938. Down around 20. So you got 10 thou take up on this. We got 25, so we got about 15 thou compression this O-ring's got to withstand for this nut to go on it per side. That's quite a bit. There's not a lot of room, there's no room in the groove to go sideways. It's not like it's loose. So I think this O-ring's too thick. What do we got in our pile? Let's see here. Got a bunch of leftover stuff like this. Oop. Well, we lost one now. Alright. First thing I'm going to do is see if we got something thinner than 88 thousandths. Which is what this one was. 89. This one's a lot thinner. 67. Ooh, that's nice. What's this one? 98. Yeah, it's worse. 99. 98. 68. 66. 68. So these two are the same. They're not the same, they're different sizes. I can't hold cameras and look at everything. Okay, this is the diamond that came off. This is the two different diamonds. You can see these are different. If you can't tell those are different diamonds, you better not be working on Harleys. See how it goes almost inside the other one? So which one goes on here? We're going to take the smallest one, stick it up here, feel it. It's above the surface. Good. Is it small to go on there? Yes, it is. Okay. A little clearance in there for movement. biting on it too, so actually sealing. There. So this would be the correct O-ring. This big thing they stuck in there ain't no damn way I'd ever go on without. So that is what's supposed to be on there. That's why this here didn't look right and didn't fit right. This one's too big to go in here. See, it goes around the whole thing, doesn't do much. This goes somewhere else. We don't know where yet. We'll figure it out later when we need it. Alright, so now we got that figured out. Now, to help it from leak, I'm going to go ahead and put some 3-bond sealer on here before I put the nut on it to make sure it has a little secondary sealing action going on. Sometimes that can cause problems, so you got to be careful about doing that. He said he wanted his clutch to be dry. I told him that would never happen, but he didn't believe me, so we're going to try. Okay, we already got a seal in there. Damn, the push rod. Damn it, the push rod seal is in there, but there's nothing in it yet. Okay, we got 4 push rods here that need to go in there. They don't all go in from this side. So the precision way of doing this is you have a big long one, you have a little short bastard, you have a big fat one that goes over there, and you got this one that goes over here. The problem is when you go to put this one through here, it drops down in there and sometimes you're screwed. So you need to put it in from the other side, if it'll go all the way through. They don't always go all the way through. So we don't know if it'll go all the way through or not. Now there's no bearing here, these are just 4 surfaces that rub against each other inside of a shaft. So you gotta make sure you lube this stuff up with a lot of grease and hope it lives. And if you have a heavy duty clutch spring on there, you will burn them up. Guaranteed. Especially if you're stupid and do like they tell you to do in the rider's training. Hold your clutch in at a stoplight or stun until it's time to go. You do that about twice, you won't have a clutch anymore. So you don't always believe everything you're told. Okay, you take some of the lubricant material, stuff it in that hole right there. You take your small little one, you put a little bit of dab of junk on it like that, from both sides, stuff it in the hole. And you take that one and do the same thing. Lubed. If we're lucky, that'll go all the way through. We're looking pretty good. Okay, this one over here, lubricate it up a little bit. Well lubed. Most of that won't be ever used. Actually, on that one it might go through, but okay, nope. Yeah, just got that dirty. Now you stuff this in the seal on the other side. Goes. You have to kind of rotate and push a little bit because it's kind of a sharp edge. Once it pops in, you're good. If you force it, you'll shear the seal off and it will leak. Okay, so now the last one here. So one side goes against the push rod and one side goes against the adjustment screw. Both sides look like they've been burnt from lack of lubricant. This one's all kind of torn up looking. This one looks the smoothest, so let's put the smoothest one on the inside. Put a good wad of junk on that thing. Stick it on in there. Okay. Wipe off the mess I made. Okay, so now you have a push rod right here. You have a push rod right here. It should be connected and work freely. They appear to be working freely. That is a very good sign when they do that. Alright, I like that part. That was good. Okay, so that's now in there. Now remember how we didn't put this sprocket on over here before? There's a reason for that. We had to get all this junk together. Okay, now here's your sprocket. We need to put some grease on this. This is a sealed surface out here. Needs lubricant on it. The inside doesn't matter. Okay, so that right there. That's not very good. It slipped down without any motivation from a hammer. That's not good. You don't want to have a tight spline if you can have it. That one's not tight. Oh well. Okay, you need a lock tab. You need a nut with a seal in it. Now this rubs on the end of the main shaft also, so you need to make sure it's got a bunch of junk in there like grease. You notice the older the bike is, the older the motor is, the more grease you got to use. Do you ever notice that? Okay, lubricate the seal area pretty good. Make sure it's lubed up. Okay, that looks good. Now I'm going to hold the pusher off from the other side because I have to jam that thing through this small hole here. You don't always like going through. So you just kind of wobble around a little bit until it goes all the way through. That went pretty easy. Now you're going to tighten this down. Now the problem with this nut is, this is a Taiwan Teddy nut. The stock nut has a through hole, the rubber seal, and like a freeze plug cap. It's not a freeze plug, but it's like that. It's pressed in steel cap, or tin cap. So when that bottoms out in there, if it's too much tension, it will just pop the cap off the end of the nut. You know there's something wrong. This one, you tighten the nut down, it could be just rubber against rubber, and the nut's actually loose. You don't know that until the rubber gives away. When the rubber softens up and gives out, then the nut becomes loose, it falls off. That's what the lock tab's for. But the problem is the sprocket gets loose in the shaft and eats everything all up. Now this one's already loose, which is not a good sign. So you want to make sure this thing's all full tight, but we don't know. There's no way of knowing. We just tighten the piss out of it and hope it stays that way. It's this 1¼ inch socket. Now, what you got to do is you got to hold on to this thing. I suggest you use some kind of a foreign material like a towel to hold it. Don't get your finger caught in here, it might hurt. But hold on to the damn thing. If you're a pussy and just let it kind of be a little loose, you'll get hurt. You got to hold on to it as hard as you can. If you're afraid of working on bike, don't work on them. See, no damage. If I didn't hold on it tight, I'd get caught in there, it could rip my finger right off. Okay, so it's tight, as far as I can tell. We got in play, that's good. So now we just fold our tab over. Get it going in the right direction. You can whap on it with a hammer. Use a pair of channel locks. Go like that. Boom, it's long. Now these actually are channel locks, so I can call them channel locks. Even though they're the ones that made them to begin with anyway. That's why everybody calls them channel locks, even though they're not. Mine are. Okay, make sure it still goes in and out. It does. Sprocket's on. So I don't think I got a cover with this project. So I'm done if I don't have a cover. Can't check anything else on this side. Go back on this side. Key floating around. Okay, so now I got more stuff to do. Alright, I'll be back in a minute.